welcome back. It's always a happy day to see you again watching these videos. And in this lecture, I'm going to go through halogenation. And if you remember, the first reaction that we went through, it was hydrohalogenation. The second was acid catalyzed hydration. And this video, we're going to go through just halogenation. That means the condition we use must be non-technical, non-protic or a protic, a protic solvent, a solvent that's not capable of donating H. So I go with a protic solvent or non-polar. And one of this solvent, it can be, for example, CCl4 carbon tetrachloride. It's completely non-polar and it doesn't have acidic hydrogen. Okay, and okay, let's go after this reaction. Okay, a reaction is going to happen between an alkene and chloride or bromide. Okay, and we have, for example, okay, let's say we have bromide, and bromide is attached to another bromide, and each bromide it has 3 lone pair. Okay, and so let's assume one of this is a central atom. It means this is going to pull, and for short time we're going to have a positive charge here, and this one, for example, negative charge. Okay, for short time. And so I have a double bond, and this double bond is going to behave as a nucleophile, and a double bond, it will go after one of the bromide. Okay. And what do I get? I get bromide somewhere here. So this is going to be a bromide attached to 2 carbons. And the bromide, it will have a positive charge. Remember, each of this carbon, it has hydrogen. Now, the bromide that is attached from the top of the ring, hydrogens, they go down. So I'm going to put the hydrogen down there. Or I can add the bromide from the bottom of the molecule. So if I add bromide down here, that means hydrogens will be this position. Okay, maybe I need to move this one down there. Okay. That's going to be hydrogen. Oh, forgive me. Okay, those 2 are hydrogens. Now, bromide, again, it has a positive charge. That means we're going to have a ring. And where is that ring? This is the ring that I'm talking about. That ring is made of 2 carbons and 1 bromine, and there is a positive charge there. So it means this carbon, those 2 carbon, also they have some positive charge, because the positive charge is not going to be absolutely just located on bromide. Okay. Now, next, what will happen with the second, bromine atom? The second bromine atom, we have we have a bromide here. Bromide, it has 4 lone pairs. So that means it has a negative charge. Okay. And that bromide, it can attack. Okay. It can attack this carbon. Okay. It can attack either that carbon or that carbon. In this case, they are the same, like they have exactly the same group, same substituent. So it doesn't matter which one we attack. Okay. But keep it in your mind, addition, it cannot happen from the top here. Why? Because the top is already taken by bromide. So if you want to add the bromide to it, bromide has to reach it from the bottom of the molecule. So I'm going to show it by an arrow. Okay, bromide. Okay, next step, bromide, it will attack either that carbon or that one, but it has to be from the bottom of the molecule. Okay, so it has to attach it and reach it from the bottom. Okay, and how about this? In this case, it will reach it from the top. Again, we can attack both carbon. It doesn't matter which carbon you go after it. So I can draw this one also that way. Okay, and now let's add the next bromide. Okay, so this bromide is going to behave as a nucleophile. This is going to be our nucleophile, and we will add the nucleophile to the intermediate. And the nucleophile, it will be added from the untied position. Okay, what does it mean? It means the addition, it will happen from bottom of the molecule, wherever you have the intermediate, wherever you have the bromonium ion, or this bromine that's made a ring. And if it's sitting at the top, then the bromide or the nucleophile, it will reach it from the bottom. Or if then like the bromonium is on the bottom of the molecule, then the bromide, it will reach it from the top. Okay, so here I have 2 carbons. This is going to be carbon number 1, and that's carbon number 2. If the addition happen, okay, to like forgive me, if the bromide attack carbon number 1, if attack carbon number 1, I'm going to have bromide at the bottom, Which bromide? The new one that we are adding. I'm showing it with the blue color. Now, what will happen to hydrogen? Hydrogen is going to go up. Why? Because we added, okay, we added the nucleophile to the bottom of the molecule. And now what will happen to this hydrogen? This hydrogen is going to show up on the second carbon, okay? So that bromide, it will be on the top of the ring technically. And we will have the bromide up. So in this case, bromide, it will be up. And I'm going to say this is original one. And what will happen with the hydrogen? Hydrogen, it will stay down here. This is going to be hydrogen. Okay, now let's assign the configuration for it. And configuration, this is going to be number 1. That's number is going to be number 2, and this one is number 3. Where is hydrogen in the back? So this is going to be our configuration. Okay, how about this one? Okay, this is going to be 1. Here is going to be 2, and that one it will be 3. So this is going to be supposed to be S, but because we have hydrogen facing to us, that one it will be R. Okay, so I got R and R. Okay, I got R and R. And if we add, okay, now if we tag, for example, carbon number 2 first. Okay, so we are going to go after carbon number 2. Okay, if we attack carbon number 2, then bromide, okay, it will be here. This is going to be the new nucleophile that was added to the system. And what will happen with the original bromide? Original bromide, it will show up on carbon number 1. Okay. So bromide will be here. And of course, I'm going to have hydrogen. One hydrogen is here. And next hydrogen, it will be there. That's going to be hydrogen. Okay. So, you know, we have a bromide that is sitting on the top of the molecule. Okay, we have to reach the system from the bottom. Okay, so we technically our nucleophile. Okay, our nucleophile, which is this, reach. Okay, this carbon from the bottom, or that one reach carbon number 1 from the bottom. Okay, and again, what do I get here? I get, let's assign the configuration. I go 1, this is going to be 1, this is going to be 2, and that one 3. So this is going to be S. Okay, and next one I go 1, here we have 2, and that one will be 3. So I go 1, 2, this is R, and because hydrogen is facing to us, is the 4th priority, so this is going to be S. Okay, now what's the relationship between these two? Like the first molecule and the second molecule. Okay, and let me erase those numbers just to make it more, you know, clean. Okay, so those numbers are gone. Okay, now, so the top one, it says RR. The second one is SS. So I'm going to say these two are enantiomer. Okay, these two are enantiomers. Okay, and again, we don't have a mirror here or inversion center, so each one optically it will be active. But we're going to get 50% from each one. Okay, 50% from each one. So the mixture optically it will not be active because we have 50-50 from each one. Okay, but the relationship between them it will be enantiomer. Okay, enantiomeric technically. Okay, next one. I have cis and trans. I want to know what's the relationship between those two. These two are diastereomers. Okay, these two are diastereomers. Okay, I want to know what's the meaning of this term. Okay, what does it mean whenever they say the halogenation is stereospecific? Stereospecific. It means this. Okay, it means this. The relationship between the starting compound, it will be hold and it will show up on the product. Right now, the relationship between cis and trans is diastereomer. Okay, cis and trans will be diastereomer. So when you get a product, let's call this one product number 1 and this one product number 2. What's the relationship between these two? These two also, they will be diastereomers. Okay, so you started with diastereomers, you ended with diastereomers. If you hold that relationship, we say the reaction is stereospecific. Whatever you started with a cis. Cis is going to give you a unique product, okay, and that it has a diastereomeric relationship with a product of the trans isomer. Okay, let's practice though. Okay, so I'm going to add bromide to this system, and what's the solvent? Let's go with CCl4. Okay, this is going to be our solvent. Okay, and the product. Okay, the first one is going to be this. We get an intermediate. Okay, we have brominium there with a positive charge. Now I'm going to have hydrogens here. Those are hydrogen, and here we have CH3. Okay, now if I add the nucleophile to it, and our nucleophile, it will be the bromide. Okay, when the bromide attack this, it will give you two isomers. Okay, so whether addition is from the top or bottom. Okay, forgive me. So say the addition happened from the bottom because the bromonium right now is on the top. Okay, bromonium is on the top. So I'm going to attack it from the bottom. If I attack this one or that one, let's see what we get. Okay. One product that I will get will be this. So let me give the bromide to this carbon. Okay, so I'm going to put it here. This one will be up, and the one that we are adding, it will go down there. Okay, and another possibility, it will be this one. Okay, so say copy, loss. The second possibility, it will be this one. So let me erase this bromide. Okay, and that one. Okay, so I'm gonna put the bromide. Okay, let's say bromide. We're gonna keep it here on the second carbon, and the red one we will add it to this carbon. That's gonna be the bromide. Okay, now if you assign the relationship between them, you will see that this the methyl group, is pointing to us. Okay, and as well that one. Okay, those two are pointing to us. I can draw the same thing for that methyl and this one as well. Okay, so those two substituents are facing to us technically. Okay, what's the configuration? Configuration here, you go 1, this is going to be 2, and that one 3. Carbon hydrogen number 4, this is going to be R. Okay, R configuration, and here you go 1, this is going to be 2, and that one 3. Okay, if you reach it from here, okay, this is going to be again. This one also is going to be R. Okay, so I got R and R, and then how about next one? Next one is a 1. This is going to be 2. This one 3. This one will be S. Hydrogen is back. And here bromine is going to be 1, this is going to be 2, and that one 3. Hydrogen is 4, so that's going to be okay 1 2. Okay, 1 2 3. I got this one. Okay, 1 2 3. I got this one R. Okay, let me double check the first one. The first one I got 1 2 3. This is R. How about here? When I looked at it, this is also R. Okay, and I got here. Okay, so I have this one is S. My bad. That one is S. Okay, that one is S. And because we have 1 2 3, yes, this is 1, that's 2, and here is 3, so that's going to be S. Okay, the relationship between them, I got okay, let's get rid of the numbers. So I got R and R for the first one, and the second one I got SS. Okay, so we got R and R and S. Okay, we got R, and the second one we got S. What's the relationship between these two? Oh, those two are enantiomer. Okay, non-tumor. So instead of drawing the second molecule from now, anytime that I ask you such a question, you draw one of the isomers, and for the second one, just simply say En. That means there is a second enantiomer. I know the first one is RR, so the second one must be SS. Now let's talk about the trans. Trans is going to be this. Okay, we will have brom here. Okay, of course we're gonna get hydrogen there, and we'll have hydrogen here facing to us because the methyl, it will be back, and this is going to be CH3, and that one, it will be facing to us, and this is CH3. Okay, now if you add this, okay, either to that carbon or that carbon, okay, one product that we get. Okay, so we have this carbon, and next we have, let's say, CH3 here. Okay, and we have hydrogen in this position. Okay, where do we put the bromide? Let's put the bromide. Okay, put the bromide here at the bottom. So this is the bromide. Okay, and what will happen with the red one? Red one, it will be in this position. Okay, at the back, we're gonna have hydrogen. And here, we're gonna have a methyl group. Okay, cool. And second one, okay, second one, copy paste this molecule. Okay, just simply switch. Okay, let's say. Okay, if I add the bromide, okay, let's say I'm gonna add the bromide here. The black one, I will add it to this carbon. That means the bromine, the red one, it will be here. Okay, let's assign the configuration for each one. Okay, this one is going to be 1, 2, 3. So that's going to be 1, 2, 3. This is going to be R. And how about here? This is 1, 2, 3. Sorry, forgive me. Okay, this is going to be 1, 2, 3. If we go R, and if we go R, because hydrogen is facing to us, it will be S. Okay, let's double check it. So this is going to be, yes, S configuration. How about here? 1, 2, 3. This is going to be S configuration. This one, we look at it, this is going to be S. Okay, so what did we started with? We started with SR. Okay, and again, let me double check then the second one. And second one, I got 1, 2, 3. This is S. How about here? Okay, this one is number 1. That's number 2. And this one is number 3. So rotation is supposed to be S. So we should flip it because we have hydrogen. It's going to be R configuration. My bad. So this is going to be R configuration. We got this one, R configuration. Okay, so we got S and R configuration. Now, these two, they will be enantiomer, okay? They will be enantiomer of each other. But check this. There is inversion center. And because we have inversion center here, okay, we have inversion center there. So, okay, this is I. This molecule, even it has two stereo center, it will be meso, okay? It will be meso. But the one that I want to talk about it, okay? I want to talk about it. Look, let's take one of these structures. We got it from, okay? We got those from the cis isomer. Okay, so we have this from the cis isomer. I'm going to put it in another page. Okay. My bad. Okay. I think maybe I should just simply copy paste this part. It's there. Okay. Okay. So these two are the trans product. Okay, and these two are the cis product. We got them from the cis. Now, what's the relationship between between these two? They are enantiomer. Okay, how about these two? These two are also enantiomer, and we said we have inversion center. But what's the relationship between for example, okay, this one and this? Okay, if you looked at it, one of the stereo center, okay, got flipped. Okay, well, the second one. Okay, here, the first one stayed as it is. If you flip one stereo center, but you keep the second, in that case, I'm going to say you are dealing with diastereomer. So these two are going to be diastereomer. Okay. And you have the same story with those two enantiomer, S stay as it is, but but the second S got to flip to R. Okay, one of them got to flip. Okay, so one of them got to flip while this stayed as it is. Okay, so if you have one stereo center that stay as it is while the second one get flipped, then we say you're dealing with diastereomer. So here, the bottom line of this sentence, when it says stereo specific, you started with diastereomer. Your product will have diastereomer relationship. Okay, and this is going to be technically end of this chapter. And this lecture. And thank you very much.